Hey everyone, my name is Daniel Wilczak and I'm one of the creators of EasyGA. Today I'm going to show you how to get started with EasyGA, the Python package, to make genetic algorithms a little bit easier. Let's get to it. Alright guys, so I'm on the GitHub page. We're going to get started by just pip installing the Python package. Just a disclaimer, you need Python 3.7.5 or greater installed. So we're going to start with pip installing it. If you don't have pip installed, it should come pre-installed with anything above 3.7, so you should be good. All right, and so we're good to go. So I'm going to clear this out. Now I'm going to take the basic code that they give on their GitHub, and I'm going to try running it and see if it works. Today I'm going to be using the Atom IDE. You can use whatever you want. I'm going to link Atom in the bottom. It just allows it to be easier for us. And if you have never heard of Atom, VS Code is also another good example of an IDE to use. I just happen to like Atom. I'm going to create a file. You can name it whatever you want. I'm going to create run. I'm going to put the code in there. And we can see that we got throughout all the way to 100 generations, and we can see that we got a score of 10. Now, what does this kind of mean? Well, how EasyGA works is it works off of defaults. These defaults are for the fitness, are for the chromosome length, the population size, mutation rates, everything. And we do this because there's a lot of parameters needed for a genetic algorithm, a lot of parameters that a lot of people don't even want to deal with when they're first getting started with genetic algorithms. So we said, all right, let's build a Python package that gets rid of all these things. And so as we go on through this video, you'll learn more and more about these attributes, how to change the sizes, how to do all of that. So as we can see, we're gonna go over the code a little bit. I've imported the EasyGA package. I've set up a variable that takes the entire EasyGA package and stores it into one variable. Then we evolved it, so all of those defaults were evolved. Then we printed out the current generation and the population. All right, perfect. So probably a lot of people are gonna ask, how do we change this? So perfect, we'll go to the wiki, we'll see the attributes, and we'll change it around. Here we have chromosome length and population size. So I'm gonna steal this code, and I'm gonna put it above the ga.evolve. Now ga.evolve is basically like saying, I want you to evolve my genetic algorithm. And anything above that is going to be considered a parameter of how it'll evolve. So for example, if I wanted to change my population size to maybe 5 and the chromosome length to 3, I could do that. While I do that, I'm going to actually change the generations, and we'll see how this works out. All right, so we're going to save it again. We're going to hit run. And we can see that our chromosome length changed to 3, our population size was down to 5, and our generation is at 10. So these are the attributes, the basic ones that we use just to change size that a lot of people will want to play with. All right, so now let's go a little bit more in depth into it. Oh, so there you go, you can see the other example. Now, that doesn't like really help us at all, because great, we could change the size, but what are we changing the size of? Well, we're changing the size of a default chromosome that was built for us. In this part of the tutorial, we're going to think about the genes and the chromosomes that are in it. So as you can see with these awesome tutorials from Among Us, if we wanted to change the gene implementation, we could see that it's used to change everything but with one function. And if we don't want that and we want each gene in there to be separated, we could use ga.chromosome implementation. This allows us to change every single gene in chromosome. All right, so I'm going to copy this over. Now, some of you might recognize this as if you're Python people, but you'll notice that it uses a lambda function and then it uses the random.randint. So random.randint is basically asking for Python to give me an integer between 1 and 10. And we have to import the random Python package. All right, so let's say we don't want to use 1 through 10. Let's say we want to use 1 through 20. So we'll save that, hit run again. And you can notice now that there's 20 in there, and 18 and 3 and all these different kind of numbers, right? This shows that now we're running run through 20. Now I'm just going to change the population size and the chromosome length to make this more clear for everyone. So I'll make that 10, I'll make that 10. Now let's make the generation go a little bit farther. So we'll say 20, or we'll say 50 for it. All right, so we could see that we got 7 now, but you could see there's 13, a bunch of 5s, a 15, a 5, a 10, and we can see that we're changing this. All right, and on the documentation, they actually state how we could use uniform for floats, or we could actually put in strings itself, using the up, down, left, right, whatever type of string you would want to input into yours. The GA chromosome implementation is the same thing, except now we're going to use a combination of them. So here we could use random.range, random.uniform, or choice like we just saw. This is also able to be done using a user-defined function. So we'll define a function and then we'll return it. So I'm going to copy this code actually and try running this and see how it goes. Let's clear this out. Let's run it again. And as you can see now, we've got 11, which is an integer. Then we've got a float, and then we have a string at the end. And of course, the fitness has none because we're using the default fitness, which uses numbers. But we'll see how to change that later on. All right, so now we've gotten done with genes and chromosomes. But what does that do for us? Great, we can change the size of our genetic algorithm. We can change what it's being affected in it, so it's genes and its chromosome. But genetic algorithms' main focus is how you evaluate these genes and chromosomes. So we need to change our fitness function. In EasyGA, there's 2 main type of fitness functions, but you could always change them. But we categorize these to make it a little easier. We categorize them into maximum or minimum fitnesses. Now, what do these mean? So let's go into it and I'll explain more. All right, so max is set by default. This basically means we're trying to make the fitness function go up and up and up. So like we saw with our 5 example, the more 5s there were, the higher the fitness would be. This is one approach to genetic algorithms. Another approach could be, let's make it smaller. So let's reduce some type of error, anything like that. And we'll see 2 types of examples. So here we could see what we've been working on with the 5s. We could see that it's called isIt5. We start with a fitness of 0, and then for each gene in the gene list of that chromosome, if the gene equals 5, let's add 1 to the fitness. And that's it. That's all you have to do. So once you establish your fitness function, there's one more thing you have to do to get it working inside of the bigger package. That's all you have to do is change the GA fitness function implementation to whatever the name of your function is. That could be a Lambda expression, or it could be a user-defined function like we have in our example. So let's do it here. Let's copy this code, and instead, I'm not happy with the number 5 today. So we're going to change it up and say I want all 7s. Why 7s? Because 7s are lucky numbers. So let's clear this out. Let's run it. Okay, and now we could see that the chromosomes are all searching for something with 7s in it. And we scored about a 9 with 100 generations. If I raised the generation limit, this would fix that, or the chromosomes, or the population size. So from going on from now, we've only showed the ga.evolve function, which just runs the entire thing and doesn't show you how it got there. So we established a way to run and ways to print. Ways to run is basically a way of saying, hey, do you want to evolve the entire thing? Or do you want to do something intermediate between the generations running? So for this example, I'm going to show how we can show every 5 generations of the default fitness function or the default setup. So I'm going to copy this code over here, change it over, and we're going to run it, and then I'll explain it. All right, so we noticed that it's printing out a chromosome, or the best chromosome, for every 5 generations that it has. In the code, you can see we do the standard import EasyGA, we set the attribute or the variable GA using the package, then we use a while loop to say GA.active, then GA.evolve 5 generations. Then for each generation, we print that generation number, excuse me. Then we print the best chromosome, and then we just show a line to separate them. So if you were making a genetic algorithm and you needed to show how the wheels of your car or whatever you want to use are changing over time, this is one approach to doing that. Now, this is great, but I don't want to read each one of my data points every single time I want to do that. So another approach that data scientists and kind of people working in genetic algorithms use is they use graphs. So we built that into EasyGA as well. So let's go over to the graph data, and we can see that it's as simple as using something called ga.graph, then the type of graph you want, and then gagraph.show. So we're going to use the default one showing the highest value chromosome for each one, because our default is always trying to raise that value. All right, so let's go back into Atom. Save that. Let's clear out here. All right, so we can see now that there's a relationship between generations and its highest fitness. So we can see the generation number from 0 to 100, and we could see the growingness, and this one actually raised to 10, so we would have had a perfect solution here. And so that kind of shows you how to do it. So let's build a full application for our example of getting all 7s in the chromosome. Take the example we had, and go back to here, take this out. And so now I have my function that we're going to change to 7 because lucky number is 7. We changed our ga.fitness function to isit5, which is written up here. Our gene implementation is 0 to 10. And then we changed our size of the defaults because it was working for us. We GA evolved, then we have GA print generation and GA print population. Then underneath that, we wanted to print each chromosome and how it did. So we're going to save that. We're going to run it. Now you can see we had a high score of 10 at a point around the 90th generation. We can see the graph and we can see the results at the end. Now this is just a start to how our EasyGA works. This is also just a beginner's guide to it. So if you want to go more in depth, I'm going to have a part 2 where we build a password cracker using the EasyGA Python package. And so stay tuned. I'll have the link to it at the bottom. I'll also have the link to the wiki at the bottom. Awesome. Thanks guys. See ya.